Hi guys. So today what we're going to do is look at some applications of these sine and cosine functions. So there is a link on Schoology that's going to show this one a little bit visually for you, so you can see kind of why it's a sine and cosine graph. We also saw that in class. But what we're going to look at for one example is a wheel, okay? Any type of this kind of circular motion is really going to show a sine or a cosine function. Because if you think about it, the sine and cosine function is just kind of unraveling the unit circle. So here's our first example. We're standing in line to ride the Texas Star Ferris wheel at the State Fair of Texas. As you're waiting, you notice that while riding the Texas Star, a person's distance from the ground varies sinusoidally with time. Now that's just something that's true when you look at a wheel turning or a circle turning. That could be true about a car tire or many other things. So you read in your guide to the State Fair of Texas, the Texas Star has a diameter of 212 feet. You notice that it takes 82 seconds for the wheel to make one revolution. As you approach the loading dock, you estimate that the passengers load the cars 8 feet from the ground. So it's your turn to load the Ferris wheel. But what happens is you get on the Ferris wheel, but then you kind of get pushed back a little bit before you actually start. So you're not really starting from the very bottom. And then you go around and around. Then you start your stopwatch when you go up the wheel. It takes you 50 seconds to reach the top of the Ferris wheel. So the first thing you want to figure out is how high is the top of the Texas Star from the ground? Well, if you load cars from 8 feet and it has a diameter of 212 feet, then the highest point would be 220 feet. All right, how long does it take the Texas Star to make a half revolution? So let's think about this. It takes 82 seconds for the Ferris wheel to make one revolution. Well, then if that's the case, it's going to take 41 seconds for a half of a revolution. Now, it took you 50 seconds to make it to the top. So then, let's say you're on this Ferris wheel, okay, you go to the top. That takes you 50 seconds. The reason it's taking it more, remember, you're not really starting from the very bottom, okay, you're starting from a little bit further back because you got pushed back a little bit. But it still takes 41 seconds to basically make half of a turn. So up here, it's 50 seconds. You turn again, that's another 41 seconds. So 41 plus 50, it will have been 91 total seconds when you are back at the bottom. All right, if we stay on the star again, we're going to go back to the top. So that's going to be another half of a turn. So I'm going to do 41 plus 91. So at that point, it will have been 132 seconds to be back at the top. So what we're going to do is we're going to plot all of these points on a graph. All right. So let's just use all of the information that we just talked about. Okay. We're going to mark height versus time. All right. So let's mark what we know. Okay. We know it took us when the time was 50 seconds, we were at the highest point on that Ferris wheel. We determined that the highest point was 220 feet. Because the bottom was at 8 feet and the diameter was a distance of 212. All right, so now let's think about, like it said, it took 41 seconds for half of a turn. So at 91, we were back at the bottom. After another 41 seconds, we're back at the top. And that's going to continue that same pattern over and over and over again. Okay, if you think about it, the distance from the top here, okay, 132 minus 50, that's a distance of 82, which is what it told us, 82 seconds. So if I wanted to get more and more points, I could, but this is enough to see what this graph's going to look like. That's one cycle of this sine or cosine graph. So what we're going to do now is we're going to write the equation of this graph. So this is what we did 2 classes ago, and we looked at a little bit last class when we were drawing the graphs. So in order to write the equation, it's going to be A. We can do sine or cosine. I will tell you guys, most of these graphs are going to be easier to write as cosine because it's going to be easier to find those high points. So I'm going to go ahead and write cosine. And then it's B, x minus C plus D. All right, let's remember what these things stand for. A was the amplitude, and D was the vertical shift. Let's do those first. Vertical shift is the middle height here. Now that middle is not marked, so we need to figure out what it is. Well, to figure out what's in the middle of 220 and 8, okay, you're kind of finding the average. So 220 plus 8, and then we divide that by 2. So I figure out that my middle is 114. So that's my D value. Amplitude, that's the height from the middle to the top. Or middle to the bottom, it'll be the same height overall. So the distance between there, 220 minus 114, is a distance of 106. So that's my amplitude. All right, B, remember, is 2 pi divided by the period. The period is how long it takes to repeat itself. Well, we already figured that distance out. Okay, it's a full circle. It took 82 seconds. Okay, on my graph from the high point to the high point is 82. So B is 2 pi over 82, or pi over 41. The last thing we would need is the C value. Okay, C, remember, for cosine, we're looking for the x-coordinate of a high point. Here's a high point on my graph. Here's an x-coordinate. The x-coordinate's 50. Okay, I can use, if you wanted to use 132, you also could. So my equation is going to be 106 cosine pi over 41 x minus 50 plus 114. Once we have this equation, we're going to use this equation to answer every question that follows. At this point, we're going to go ahead and use a calculator. So go ahead and get a calculator out. All right, so what you're going to do is you're going to go to graph. And we're going to type that equation in. So that was 106 cosine. And then I'm going to open a parenthesis. I'm going to do a fraction. And then I'm going to do pi, which is shift, and that little times 10 down there at the bottom. And it was pi over 41. And then remember, we opened a new set of parentheses. A lot of times that's a mistake when people type this in. All right, and then we said it was x minus 50. Now there are two sets of parentheses to close. You'll notice on mine there's a different color. I've got a red one and a blue one to close. And then I have that shift of plus 114. All right, once your equation is plugged in, we can go ahead and graph it. And you may notice a few problems here, okay? Depending on how your window looks, how your setup looks, you might not be able to see any of this graph at all. And we don't want to just zoom out like we usually do. We want to really get a good picture of this graph because of the types of questions that we're going to need to answer. So what I'm going to do is I'm going to change two things. First of all, because I used on my B value, pi divided by 40. I did 2 pi divided by the period, 2 pi divided by 82, which means I used radians. So my mode can't be in degrees. My mode needs to be in radians. So I'm going to go to Shift, Setup, and I'm going to go down until it says angle, and I'm going to change that to radians. All right, so that's going to help me get my picture a little bit better. What I also need to do, so there's a little bit of my graph, not enough though. So I'm going to go to my window, okay, where it says V window on F3. We're going to make our window match the picture that we just drew. So here's the picture that we drew. If you look at your x-axis, okay, that's our time. We don't really care about negative time. So my x min is going to be 0. Then if you look, we needed 132 seconds in order to actually see a full cycle of this graph. So my x max probably needs to be at least 132. So I'm going to make my x min 0, and my x max, I'll make it 150. That's a little bit more. All right, let's go back and look at our graph and look at our y values. Okay, don't worry about the scale and dot. That won't be a big effect. We really need to worry about min and max. Okay, on our y's, okay, again, y stands for height. So we don't really care about negative height. I can make my y min 0, or if you really want to, you could make your y min 8. My y max, though, has to be at least 220 to be able to see the highest point on this graph. So let me go ahead and change my y min to 0, and I'll make my y max 225 just so it's big enough to be able to see my graph. Well, now I can see a really good picture of this graph. All right, so what we're going to do now is we're going to use this graph to answer our questions. So the first question that's on there, it says use your equation to determine your height above the ground after it says 15 seconds, 75 seconds, and 5 minutes. So what this wants to know, x is time here. So this is saying when x equals 15, what does y equal? When x equals 75, what does y equal? Now for 5 minutes, we can't just use 5 because that would be 5 seconds. I would have to do 300 because again, 5 minutes is 300 seconds. But again, I'm still trying to figure out what does y equal. Well, to figure that out from this graph, what I'm going to do is I'm going to go to gsolve, and then I'm going to go over to F6 here. And I know the x, I want to know the y. So I'm going to choose ycal, which is F1. It says enter my x value. Well, I'm going to do 15. So when x is 15, that tells you your y value. It's a little bit cut off there. I can't quite read if that's a 10 or a 19. So let me change my settings here just a little bit. So I can, there we go. I can see that is now is 19. All right, so when x is 15, my y is 19. So it's 15 feet above the ground. All right, let's do another one. Well, actually, before I do that, let me just shift this down just a little bit so I can see these points a little better. All right, so gsolve. I'm going to do ycal when x is 75. When x is 75, y is 78. So it's 78 feet above the ground. All right, now I'm going to go ahead and do gsolve. I'm going to do ycal, and I'm going to do 300, and I'm going to get... Okay, so if I go ahead and plug this in as it currently is, I'm going to get an error, all right? And the reason I'm going to get an error, it says out of domain. What that means is our window isn't big enough to find that value, okay? So whenever you do ycal, whatever x value you're plugging in, your window has to be at least that big. So I'm going to go ahead and draw this again, and I'm going to go back to my window. I'm going to make my x max at least 300 now. That's the only way that this is going to work. So now I can see enough. I'm going to go to gsolve. I don't know why I did shift. You could. Gsolve ycal when x equals 300. I'm 215 feet above the ground. All right, question number 7. It says, when you started the stopwatch, what was your height? All right, well, when you start the stopwatch, that's an x value, okay? Starting the stopwatch is when x equals 0. What does y equal? So when x equals 0, so what I'm going to do is I'm going to go to gsolve again. I'm also going to do ycal. X equals 0. All right, well, it tells me I have a height of 32 feet. But the next question is a little bit different. It says, after that time, were you moving up or down? So that's when we really need to be able to, this is why we have to see a good picture of our graph. Okay, it's hard to tell if you're moving up or down if you've just zoomed out or zoomed in an incredible amount. So if you look at that point, what happens, your graph then goes down after that point. So you are moving down after the height of x equals 0. All right, the next question, it says, after how much time are you 100 feet off the ground the second time? So what that means, okay, you're 100 feet off the ground more than one time. Now there's 2 ways to do this. One of them, all right, is I can go ahead and do my gsolve, and let me go back up so we can see this. There we go. I can do gsolve again, but this time I would do xcal. I want to know when y equals 100. But again, I want to know the second time. Right now, it's showing me a point when I'm 100 feet off the ground, but that's not the first time, or that is the first time. That's not the second time. I want to find when it's 100 feet off the ground the second time. So if you'll notice, it's going to be 100 feet off the ground. That wheel is going to keep going over and over and over and over again. So the point I really want is that point right there. So in order to find that, the way you do that on your Casio is you just click the right arrow, and that's going to give you the next one. So the second time, I'm 100 feet off the ground when x is equal to 72, so after 72 seconds. All right, let's try the next one. Same concept, after how much time are you 175 feet off the ground for the 4th time? So we're going to do gsolve. I want to know what is x when I know y. So I'm doing xcal, y equals 175, and I want to know the 4th time. So I'm just going to go, there's 1, 2, 3, 4. This is why, again, it's good to change your window. If your x min is 0, then the first one it gives you is going to be the first time, and you can just count over 4. If your window's different, we can't necessarily do that. So it's important here to get a good window set up. So for that last one, after how much time you're 175 feet off the ground the fourth time, that is going to be after 144.5 seconds. All right, so that is all we have for today. Again, the biggest thing about today is going to be kind of sketching the graph and writing the equation. Once you know that equation, you can plug it into your calculator and use your xcal and ycal to find all the values you're looking for.